Hello, welcome back. Today we're going to be talking about direct and inverse variation. The objectives are that by the end of this video, you should be able to classify given functions as directly or inversely proportionate from an equation, graph, and problem situation. You should also be able to write and solve direct and inverse variation equations. Let's take a look at direct variation. Two variables vary directly with each other in the following ways. We're going to look at an equation, a table, and then a graph. The first one is an equation, y equals kx, where k is a number other than 0. The key feature of this equation is that y is equal to a number times x. Again, that number cannot be 0, and this is the only thing you're going to have on the other side of the equation from the y. It's just going to be a number and x, and that's it. Looking at direct variation as a table, notice we take the x values and we multiply them by k every single time, whatever the k happens to be. The key features of the table is that the table will always include 0, 0. Also, your y values have to be equal to the x values times the same constant. In other words, k has to be the same number every single time. As a graph, y varies directly as x, or y varies directly with x, if when you graph the equation you end up with a straight line that goes through the origin, or 0, 0. Let's take a look at inverse variation. Two variables vary inversely in the following ways. As an equation, y is equal to some number over x. The equation will always be in the form y equals to a fraction, where x will be in the denominator and a non-zero constant will be in the numerator. As a table, inverse variation, you'll notice that the 0 is undefined. That's because you cannot divide by 0. So if the input is 0, the output will be undefined. Also, the y values will be equal to the same constant divided by the x values. Notice every y value is equal to k, our constant, divided by some number. Negative k is because we took k and divided it by -1. Positive k is because we took k and divided it by +1. As a graph, inverse variation looks a little bit like this. Notice the graph cannot cross the origin, meaning 0, 0, cannot cross the x-axis, and cannot cross the y-axis. The graph contains two parts that are mirror images of each other. Notice we've got a portion to the left and a portion to the right that look like they've been reflected over a line going through the origin. Based on the definitions of inverse and direct variation equations, please classify the following equations as direct variation, inverse variation, or neither. Go ahead and pause the video, try it out, and press play when you're ready to see the answers. The first example would be direct variation, because y is equal to some number times x, and the number is not equal to 0. The second equation would be neither, because you're adding 1 to a direct variation equation. The third equation would be inverse variation, because you're taking some number and dividing by x. The fourth example would be neither, because you have an inverse variation equation, but then you subtracted 6. The fifth one would also be neither, because you're not allowed to have your number that you're dividing by x be 0. And the last equation is also neither, because x should be in the denominator, not in the numerator. Please classify the following tables as direct variation inverse variation, or neither? Please press pause, write down your answers, and press play when you're ready to see the problems worked out. I've started the first two for you. The first one is inverse variation, because y is equal to 4 over x. 4 divided by negative 2 is negative 2. 4 divided by negative 1 is negative 4. 4 divided by 0 is undefined. 4 divided by 1 is 4. 4 divided by 2 is 2. The second example is direct variation, because y is equal to 3 times x. We can take all of the x values, multiply them by 3 to get the y values. The third example is neither, because you are not allowed to have 0 paired with 1 in either direct or inverse variation. The last one is also neither, because there is no consistent pattern between the y values and the x values. Please classify the following graphs as direct variation, inverse variation, or neither. The first graph is an example of inverse variation, because it meets our criteria that we've defined so far in this class as being inversely proportionate or varying inversely. The second one would be direct variation. Let's take a look at a couple more. This example would also be inverse variation, because again it meets the criteria we've set so far. The second example would be neither, because it does not pass through the origin, yet it is a line, so it doesn't work. The third example, probably the most difficult, is also neither, because you notice you do not have a mirror image on the other side. So this one is also neither. We're now going to take what we learned about the equations of direct and inverse variation and solve some problem situations. Our first problem situation tells you that you're going to raise some money at a fundraiser and that money is directly proportionate to the number of participants. So anytime you see the words directly proportionate, you know that you're going to have an equation of y equal to kx, where y is the amount of money raised and x is the number of participants. We could have almost an equation completely set up with the exception of one thing. We do not have our value of k. So what we need to do is we need to read further to see if we can substitute values in for x and y in order to solve for k. Let me show you. The amount of money raised for 10 participants was $1,000. So the amount of money raised, being $1,000, goes in for y. Equals k we do not know, but x we can find because x is 10 participants times 10. We can then solve for k by dividing both sides by 10, and we get 100 is equal to k. So we can work out the first part of our instructions, which told us to write an equation by writing down y equals 100x. That's the general form of our equation for this situation. All we had to do was find k. To finish solving the rest of the question, how much money will be raised for 53 participants, we just need to find out what 53 stands for in our equation and substitute that amount in. 53 participants stands for x, since x is the number of participants. So we know that y is equal to 100 times 53. This means that the amount of money we raise is $5,300. On your own, go ahead and try to write and solve an equation for the following situation. Note that the amounts are directly proportionate. I've started the process for you by writing our general form of our direct variation equation and substituting the amount of money earned, $2,300, in for y and 2 in for x. We can solve for k by dividing both sides by 2. This gives us that $1,150, or rather 1,150, just the number, is equal to k. So we can write our general equation as y equals 1,150x. To finish solving the problem, we're asked how much money, again money stands for y, would she make over 6 years and 6 months. We do not know y, but we know that y is equal to 1,150 times 6 years and 6 months would be 6.5. 1,150 times 6.5. We're going to go ahead and use the calculator. 1,150 times 6.5 equals $7,475. And that's the amount of money she earned over 6 years and 6 months. Let's look at an inverse variation situation. Your dentist determined that the number of cavities developed each year is inversely proportionate to the total number of minutes spent brushing your teeth. If you developed 4 cavities this year after spending 30 seconds brushing daily, how many annual cavities can you expect after brushing for 120 seconds? As you're reading through this problem, you might have noticed that the word was not directly proportionate. The words they used in this example were inversely proportionate. That means we're going to be using a different equation than we did last time. For this one, we're going to be using the equation y equals k over x, where the number of cavities will be y, the first value given, and the total number of minutes spent brushing your teeth. In this case, let's make it seconds to be more consistent with the information we're given. So the total number of seconds will be x. So if y is equal to k over x, you know that you develop 4 cavities, so 4 equals k over x, meaning 30 seconds. To get k by itself, we multiply both sides by 30. And we get k is equal to 120, which means our equation is y equals 120 over x. That's the first part of the instructions to write an equation. The second part asks us how many annual cavities can you expect after brushing for 120 seconds. We merely substitute 120 in for the appropriate variable. In this case, x stands for seconds, so we're going to put 120 over x, which is 120. So the number of cavities would be 120 over 120, which is 1 cavity. Here's a problem for you to try on your own. Please press pause, work the example out, and press play when you're ready to see the answer. I went ahead and got you started using the general form of the equation. In this example, I couldn't use x and y because the problem told me to use t and p. So the total time is equal to some constant over the number of people. Since the time was 300 hours and the people was 25, we can solve by k, for k rather, by multiplying both sides by 25. 25 times 300 is 7,500 is equal to k. So our general form of the equation then will be t is equal to 7,500 over p. To solve the second part of the question, we want to find the amount of work time for 30 people. So the amount of work time is equal to 7,500 over the number of people, which is 30. When we divide that, we get the total amount of time is equal to 250 hours.